everybody, and welcome back to the Poor Man's Chemist. In this video, I am going to be converting elemental selenium, like you see here, into selenium dioxide. Selenium dioxide is kind of the standard precursor for other selenium compounds, at least if the literature that I've read is anything to go by. And it's also used as a reagent in organic synthesis. So having a way to turn elemental selenium into a relatively pure dioxide would definitely be a nice thing to be able to do. Now, I've been after this fucking shit for quite a while. I have never really had a lot of success with making selenium dioxide. I mean, yeah, sure, I can make it. You can get the element to burn with a torch pretty easily, and it will give off thick white clouds of selenium dioxide that reek of horseradish. Oh my God. It is horrible. Horrible. So, making the dioxide isn't really that difficult, but making it in a controlled way so that we end up with a pretty pure product, that has been a tall order up until now. Thank you, Handbook of Preparative and Organic Chemistry, which gave me the key to being able to do this without having to actually burn selenium. This is still going to be a little more involved than a lot of the other preps that we've done. We've got to figure out our reaction in order to make selenous acid, which is what will be dehydrated to produce selenium dioxide. We'll also produce some selenic acid. Although how much is anybody's guess. And we have to remove that with aqueous barium hydroxide. Barium selenite is apparently soluble. Barium selenate, not so much. Very much like barium sulfate. Although barium selenate is a little more soluble than barium sulfate. Now, we are going to start this prep off by dissolving 8.17 grams of gray selenium pellets, or shot, whatever you want to call it, in hot, strong nitric acid. This will give us selenous acid and selenic acid, and then we will have to dehydrate it, get our residue, and then go from there to remove the selenate ion, and then sublime that in order to get our final product. So, here we go with dissolving this in nitric acid. Okay, so all of the selenium has dissolved. The next step is to evaporate off all of the liquid until we are left with a white residue at the bottom of the beaker. The textbook says to heat it until it just begins to sublimate. And at that point, we'll have to take it off and dissolve it in water and precipitate out all of the selenate ion with barium hydroxide. So, I will come back once all of this liquid has evaporated down, and we are ready to move on. Alright everyone, we are just starting to get solid, come out of solution now. We have to be very careful at this point. We just want to evaporate off the liquid. We don't want to start sublimating off selenium dioxide. We have to heat it until it just gets to where it's sublimating. Because at that point, we've driven off all of the nitric acid. Oh, and I'm sure this goes without saying, but you don't really want to breathe vaporized selenium dioxide. I'm not really sure what would happen, but I can't see how it would be good. Okay, we're getting there. One thing that you can do to check on, what the hell are these vapors that are coming off the solid, is to put a watch glass over it. If the watch glass is wet, like this one is, I don't know how well that's showing up, then you're still getting nitric acid, probably a little bit of water being driven off of it. If you start, on the other hand, seeing like a white smudge that starts to form up just a short ways above the solid, that's definitely selenium dioxide sublimating. Okay, everyone, so this has been evaporated down until it just began to sublimate. I am not sure if you can see it there, right on the bottom, just above the cake at the bottom here. There are some selenium dioxide crystals on the side of the beaker. Not very many, because the textbook said to heat it up until it just started to sublime, so I stopped it after I started seeing this. You can see it best right over here. Okay, now we come to the fun part of the prep, where the textbook says that we have to add just enough barium hydroxide solution to precipitate out all of the selenous acid that is probably present in our crude product as barium selenate. I'm a little concerned because, I mean, when I went and I looked at atomistry, it said that barium selenite was not really soluble either. I couldn't find a whole lot of information about that. But the textbook is quite clear in its instructions, so we're going to go with it and soldier on. What I have here is our crude product dissolved in water and then brought up to a volume of exactly 100 mils. All right. What I have here is a solution of barium hydroxide. It's on the screen what it's composed of. Its concentration is not terribly important. The important thing is that it is dilute, and it's covered with paraffin because barium hydroxide will readily react with carbon dioxide in the air, forming barium carbonate. I suspect that's why it looks slightly cloudy. It's very, very difficult to avoid that. You want to keep air away from it as much as possible. Now, what I thought we would do is put a small amount of our solution, whose volume we know exactly, into this little tube here. Then we will take this pre-weighed pipette, which I'm going to suck up some of the solution into this, and then I'm going to weigh, I've weighed the pipette empty on the milligram scale, and then I'll weigh it when it's full, and then we will add a drop of the barium hydroxide solution to what we've got in here, spin it down so we can get it all, everything to settle out very quickly, take it out, add another drop, and so on and so forth until we get no more precipitate. From that, I will be able to calculate exactly how much of this solution to add to this in order to get our shit to drop out. I have high hopes that this is going to work. It may end up being very dilute when everything is said and done. I have to evaporate off quite a bit of water, but if it's too concentrated, it's going to be very easy for us to miss the end point and overshoot it. And I don't know what barium selenite's going to do or whatever we'd end up with. But I very much doubt it is going to sublimate as our pure product. Seriously? Huh? Okay, there's no precipitate forming at all. Like, nothing. I see nothing. I hope this is showing up. Yeah, there's nothing here. Okay. My big worry was that everything was going to precipitate out with this. I mean, I know that solution is dilute, but I don't know what our product is. I mean, if barium selenate is only slightly more soluble than barium sulfate, it should crash out just like barium sulfate would. Am I missing something here? I don't see anything forming. Wait, is it getting cloudy? It might be a little cloudy. Let's spin it down and let's see. Maybe the reaction is just slow. I want to do a test run here. This is... Whoa. That's the wrong pipette. Man, I'm glad I caught that mistake. This is the selenic acid that I made a while back, several months ago. I did a video on this. Oh, that's lovely. Just get a drop of it on my hand, because why not? Alright. That's alright. This isn't some now red, lightweight pussy hole channel. Sorry, I try not to speak ill of other content creators, but God, that dude, seriously, what the fuck? Talk about having fallen far. Alright, let's see what we got here. Are we focused, maybe? Look at that. Barium selenate. Drops right out. Alright. I am thinking that if there is any selenic acid in our shit, it is a very small amount. And if we just sublimate the fuck out of our stuff, we will... Hey, we're not writing any papers with this shit, man. I mean, you know, we're not selling it to anybody, so I'm not going to stress over it if there's a tiny bit of selenic acid in there when it's all said and done. Although, I mean, at the temperatures we're going to have to get this shit to sublimate, you know, I would think the selenic acid would evaporate. I don't know. That's just my supposition. But clearly, this shit is like I thought. It is not that fucking soluble. I tested ammonium molybdate, too, because barium molybdate has a solubility that's in the same order as barium selenate, and it drops right out, too. Anything that's like this drops right out. So, I mean, and barium selenite is very insoluble. I mean, much more so than barium selenate, but it's still not all that. I think it's like less than 10 milligrams per 100 mils. So I'm thinking that's all that is. Anyway, we are, if it's barium selenate, the amount of selenate in there has to be so low that it's not worth mentioning, and we're not going to stress about it. So we're just going to move on to the next step. What a clusterfuck. Alright, so I evaporated down our solution until I didn't see any more condensation forming on the beaker. And then I let the cake of solid that formed at the bottom of the beaker cool off, and then I pulverized it with a glass stirring rod. You want to be real careful. Selenium has a tendency to reduce. It wants to be the element much more so than it wants to be compounds, kind of like tellurium does. So a whole laundry list of different things can reduce selenium compounds to red selenium. So just to avoid any unfortunate accidents like that, I've decided to just use glass with it. Now I'm going to just heat it up a little bit on the hot plate once more to just make sure I've driven off all of the water, and then we are going to sublimate this shit to purify it, and our prep will be done. So I will come back when we're doing that. Okay, everybody, after days of fucking around with this stuff, I have finally figured out the best way to sublimate selenium dioxide. The way the textbook reads and all the literature that I can find reads, selenium dioxide sublimates fairly readily. And indeed, this is true. But normally the vapor is so heavy it will rise up and deposit on, like from the bottom here where the beaker is in contact with the heat source, the vapor will rise up and then crystallize on top of the crude product. So you've got to get it pretty goddamn good and hot in order to get the vapor to form, which, by the way, selenium dioxide vapor is an interesting greenish yellow, almost looks like chlorine, to rise up here, and it will start depositing crystals in here. Now, when I did the practice run, there was virtually no material left at the bottom. So, I mean, I'm thinking it's probably fairly pure-ish already, but this will eliminate all doubt. And before I get started, just a little quick explanation here. We have a watch glass covering this with a little plug of glass wool here in the spout, the little pour spout thingamajiggy. That's just to allow pressure to equalize while keeping all the selenium dioxide vapor in the beaker. Although, honestly, it's so hard to get that shit to rise up. I'm not really worried about it getting up this high and escaping, not to any significant extent. We'll get basically almost none that will deposit on the watch glass, but oh well. Anyway, here we go. Alright, so I've done the sublimation run twice since it didn't look like everything sublimated off the bottom of the beaker like it did in the practice run. Eventually I noticed that there were crystals falling back down to the bottom, so and also that anything that was down there on the bottom was still forming little clusters of crystals, no matter how hot it was. But anyway, let's take a look. So this is the bottom of the watch glass, and you can see, well, now you can, that we got some nice crystals deposited there. Not very many, but some. And of course, in the beaker, we have a shit ton, man. There's a whole lot of it here. In the bottom of the beaker, not a whole lot of stuff left, just kind of like a crust. I am really hoping that I can just very gently scrape these fucking crystals off the side without getting into that shit in the bottom into it, and call it a day. But I'm not going to make you wait on that because I've already got a sample from the practice run that I can show you of what the final product looks like. And you can see there, as soon as son of piece of shit decides to focus, very pretty. They're not wet, actually. They have a tendency to stick together. They're very fine needles, as you can see, exactly like they're supposed to be. And, yeah, except for the kind of a pain in the ass it is to sublimate this stuff, this prep is a screaming success. I really think that if I had a quartz tube, this would be so much easier because, of course, you could just bring the burner or the torch right under the section where the stuff is, have a, stream of oxygen moving through it. All the literature says a stream of pure oxygen is the best thing to use. And, you just sublimate it down the length of the fucking tube till it gets to the end. You have very pure stuff, and everything is very easy to deal with. But if you're a backyard chemist like I'm doing here, this way works too. So, if you like that video, give it a thumbs up, subscribe, comment, share the video, donate a few bucks if you're enjoying this content. There are links in the description, and until the next one, y'all, I will see you later.